I've recorded this video like 8,000 times already, and let's see if I can actually get somewhere with it. In the beginning, God said, "Let there be light." So before God said that, there was no light. And when there is no light, you cannot see anything. Why? Well, let me give you a quick little anatomy lesson. So this is an eye, or well, it's not an eye. It's a symbolic representation of an eye. But this is an eye for our intents and purposes. And the eye has this funny little structure to it. This is a lens. Light comes in through the lens, and then that like focuses it, and it beams it into this back area here, which is called your retina, and then that sends signals to your nerve cord, which then your brain interprets as meaning things. And the way that it interprets it in the section here are through things called rods and cones. Cones detect color, and rods detect value. So these two different things allow you to essentially comprehend the world visually. If we didn't have eyes, we wouldn't have the visual sense, and our world would not be visual, and thus we wouldn't see color. That makes sense, right? Like, that's pretty intuitive, pretty obvious. If you take somebody's eyes out, they're not going to be able to see. I think we all understand that. Okay. So what an eye is actually doing is this is light. Light is reflecting, it's like bouncing off of an object, and then that's going into the lens, which is sending signals to the brain, which causes your brain to interpret that there's an object there. That's basically what's going on. So if we remove light from the equation, even if we don't have our eyeballs removed, you still can't see shit. It's like, you turn off the lights in a room, you can't see anything. Pretty obvious, right? So in order to see things, we need light. So let's turn the lights on. Whoa, what a pretty little pastel pink room and a cute little shitty representation of a box. This is lovely, alright? Now that we're in the room, we can see that there's a box on the floor and the light is coming from the ceiling. Oh, but wait, hold on, something's wrong here. This looks like a weird little transparent glass box that is somehow obscuring the background line, and that's because it's not being affected by the lighting at all. There's a light bulb up here. What's going on? We know that it's supposed to be affected by the lighting, and we know that it's supposed to be affected by the lighting because light is a part of the formula of how we perceive things, and I'm not going to go into the evolutionary... So how do we fix this conundrum? Well, obviously we need to light the box. And how do we light the box? Well, what does light do, right? Light bounces off of objects and it goes into our eye, and that's how we see that there's things there, right? But we don't need to worry about the bouncing into our eye thing, because wherever we're looking at things, that's where our eyes are. So we need to worry about the bouncing off of things, right? I'm sorry, that was more convoluted than it needed to be. Hey, this is Aloe here. I know I make a lot of jokes about inserting myself in post, but I just wanted to apologize for my absolute ridiculously disorganized speech in this video, and probably in videos coming forward. I really struggle with disorganized speech as a symptom of my mental conditions, and it is getting worse. Like, I'm actively watching this video kind of stunned at how bad some of my disorganized speech is. I used to be very fluent when giving talks like this, but even now you can kind of hear me struggling to put my thoughts into words, so I apologize for that. There's nothing that I can do to fix it, and I'm sorry, it's probably just going to be a problem continuing forward, so... Like, hey, at least I can get some jokes out of it, and I hope you guys don't mind that it's not super clean and cut and dry. What the fuck? We need to worry about the bouncing off of objects thing. So where does the light hit the object? Well, the light is right here. Okay, light extends from light sources in all directions, right? This makes sense. If you have an infinite ball of light like we have on the ceiling here, it's going to spread out in all directions from the light source, because this is how light works. And we can block the light by putting an object in front of it, say like a lampshade, and that will block the light from leaving the lamp. And if you don't understand this, if you don't understand that when you put an object in front of a light, it blocks the light, then go outside. The light will hit the top of the box, as the light will hit everything in the room. Bada bing, bada boom. Now, what about the side of the box? Well, let's think about, like, paint. Like, what if we hit this with, like, a paint can or something, like an aerosol can? Let's say we have a paint can, and we're spraying it, we're spraying the top of this box with a paint. So the whole top of the box is going to get covered, because it's all within this, like, cone of paint, right? Like, let's just say this is just a solid cone of paint. It does a great job of covering. Totally covers the top of the paint, the top of the box in paint. And then it doesn't really hit any of the other sides because, well, the side of this box it's out of the range of this paint cone, right? Like, maybe it'll hit right here, but there's nothing else for it to hit here. In fact, it's actually gonna kind of maybe be blocked by the side of the box, given that the angle is a little bit weird here. Like, it's actually a little bit kind of from the back. It's going to be blocked by the side of the box, and maybe some of the paint's going to spray onto the floor over here, and then maybe the same's going to happen over here. Some of the paint's going to spray onto the floor here. And there's this area where the paint does not cover on the floor, and then the whole side of the box is not covered by the paint. This is the shadow. This is the paint shadow. This is also where the term rain shadow comes from. In a mountain, there's no rain that falls in an area, so it's the rain's shadow, because the shadow is the absence of something. So this is the paint's shadow, and similarly, this is going to be really similar to the light's shadow. So, okay, what about this light here? I'm retconning it and saying it's just very slightly behind the box, because that is more visually appealing, instead of being directly above it. So let's say it's very slightly, it's above and very slightly behind the box. Well, if we draw a cone out here, essentially, that shows where it's heading. It's above the box, right? It's hitting the top of the box. It's gonna spread out. It's hitting the top of the box. Well, like the paint can, this whole area is going to be covered in light. But then the light isn't, I mean, it's not just magically going to hit the sides. We don't have a mirror here to reflect it. All this light is going down because it's going out from the center. And light doesn't just suddenly go like this, right? It goes in one straight path, inertia. It's going to keep going in the direction that it's going in. So none of the sides of the box are hit at all. But what about the light that's, like, coming out kind of at an angle, like over here? Well, some of these light rays are going to be stopped by the top of the box, and they're not going to be able to make it over here. And this is going to create the shadow again. And then the light rays that do not hit the sides of the box, they continue on, are going to create the lighting. So when we're thinking about shadow, when we're thinking about shading, it is of utmost importance that you do not think of shadow as a thing that is applied to a surface, but rather the surface itself. And light is what is applied. Shadow is the absence of light. Shadow is not a dark area. Shadow is not something that can be added on. Shadow exists in the absence of light. So where there is no light, there is shadow. So now that you understand that concept, you will think less of when you are rendering your scenes as you are shading them, and more that you are lighting them, because you are not applying shadow to certain areas. You already have shadow and you are adding in light. This is why a lot of traditional painters say to work dark to light, and this is something that I generally say. I actually work in mid-tones. I'll do mid and then I'll do light and dark because I prefer to work that way. But if you're struggling with your lighting looking good, if you're struggling with that, or if you just prefer to work that way, that is great advice, is to start shadow and paint with light. Because again, shadow is the absence of light. That is the most important thing that I would impart into you. So here's an interesting thing, right? I just said that shadow is the absence of light. And I also said that we can't see anything if there's no light. So theoretically, shadow should be black then, right? Why are we seeing that the side of the box is pink? Why is this shading pink? It should be black, shouldn't it? Well, that's an astute observation, audience member I just made up. And the reason why is because when we're talking about shading, when we're talking about lighting, we're talking about shading in art, we aren't referring to pure shadow. We aren't referring to pure darkness. We're referring to it relatively as the darker section of the values in a composition. And getting rid of these lines here, doing some off-screen cleanup, you might notice that our darkest value, now that we've gotten rid of the imaginary lines there that help us distinguish between the separation of planes, is our darkest value is this pink here. The lightest is the white. This is a 2-value piece. And so our darker values are what we refer to as our shadows. And we make that distinction between the literal physics definition of shadows, which is just like, the complete absence of light. But why is it pink? You didn't answer it. Why is it pink? Why isn't it black? Beyond just the artistic, why did you choose it to be this way? Well, It's because I'm implying that the room is pink. Well, why does the room being pink make the shadows pink? Aloe, you still haven't explained that well. The reason being is something called bounce light or reflective light, because you see, light does not only go in one direction down and then it just disappears. Remember that? Remember that funny little angle that I drew here where it does this? Well, you see, turns out that actually happens, except it happens when light hits a wall or another object. When light hits an object, let's draw a wall in here. Again, these black lines are imaginary. They do not actually exist in the space. They're just here for us to be able to see things while we're still rendering them in. Let's say this light here, right? This is going in all directions, so it's an orb. It's an orb. It's a sphere. It's going to come back. Maybe there's a light ray that goes here. It's going to hit this wall, and then it's going to bounce onto the cube, and this is going to keep happening. This is going to keep happening. It's going to keep happening from all these different angles. You know, there's going to be light that's hitting the floor that's going to bounce up here, and then that's going to hit the side of the cube. So what's happening is this white light, it hits the floor. Now this floor is, let's just say it's intrinsically pink. And I'm going to put air quotes around that, because if you get into the real nitty-gritty in physics of it, things don't have an intrinsic color, but simplifying it this way, I personally think makes it good. Simplifying it this way, I personally think is a good way to think about it in terms of art. So we're just going to label this as like an intrinsic color. Like in Blender, this is like the diffuse value. It's what codes a material to just be that color by default. So we're going to think about it as the diffuse or the intrinsic color of that material. It is going to hit this, and the way that we see color is white light is split up into different colors, and depending on the color of the material, it's going to absorb every color except for that color. So that was a lot of times I said the word color. Let's show this in a visual. The white light is going to hit the floor here, which is the same colors as the walls, because God forbid we hire an interior designer. And once it hits this, the white light, all of the light that is not this beautiful pink color is going to be absorbed by the floor. And so what is going to be left that is reflected is this pink color. I'm going to make it just a little bit darker so we can see it. But all of the other colors in this visible light spectrum, so like the red and the orange and the yellow, etc., all of these colors are absorbed. And then the color that is left is this lovely pink color. And then that color gets reflected. So the light bounces off. Most of it gets absorbed except for a little bit, which continues to go along the path, gets reflected, and it gets bounced onto the cube. So that is how ambient lighting works. Now, ambient lighting is going to change depending on the color of your room. If your room is red, the ambient lighting is going to be red. If your room is blue, the ambient lighting is going to be blue. So this is ambient lighting covered under white lighting. This is studio lighting. Things get a lot trickier when we talk about colored lighting, but that is something I will go over in the next video. Before I close off the video, I want to talk about an example that I personally use if I'm struggling to light a form. A bit of a very silly and probably unintuitive to most people way that I go about lighting things that I'm struggling to light is I think about it as if I was the sun. So let's just take this box here and draw it from the sun's perspective, and it would probably look something like this. Now, the way that I think about it is that anything that I can see is going to be lit by my light, because I'm a very powerful light. So anything that I can see is going to get some of my light on it. And anything that is close to me is going to be lit up more than anything that's further away from me. Think about the paint can example again. If you shoot a ball with a paint can from like 4 inches away, it's probably going to be completely covered in paint, at least the side that's facing the paint can, at least the side that's facing the paint nozzle, the paint sprayer nozzle. Anything, if you take a ball, but if the paint is shot at the ball from like 4 meters away, you'd be lucky to get even a little bit of the ball covered. And the reason being is because the paint, obviously, it scatters, so less and less of it is going to hit the ball. It's going to be carried in different directions. And this is how it works for the sun, too. Once the sun's light hits the atmosphere, it starts to get scattered, which is why the atmosphere is blue. But once the the light from the sun hits the atmosphere, it's going to start to get scattered, and then, it's going to not beam everything with the highest possible intensity, because it isn't, it's like the paintball. Anyways, so anything that is further from me is going to be not as well illuminated as anything that's close to me, and that should be a really intuitive concept that I just over-explained to infinity. So let's light it here as if that's the case. And again, you might have noticed that just what is happening here is I'm not painting in any shadows. I just painted in the light because the shadows are the same color as the background. And so what you can see here is this top, because it's like completely in my vision, is all white, and then as it gets further and further away from me, as we can see in perspective, it gets darker, more towards the environmental light. What I did here in order to paint this in is I just painted with a light. I'm using a square painter brush here with the opacity on. You can do this with literally hard round just with the opacity on, but I like the square one because I like the texture of it. But all I'm doing here is just painting in the light. I'm not painting in any shadow at all. And then what I'm going to do is I'm just going to blend these colors in so it's a lot more smooth. And that's a lot more convincing than if I just like took a black marker and shaded it in. Like, that's not convincingly lit by the sun. This looks like it's lit by some red light somewhere else and that it should be in a black room. This isn't tricking our brains into thinking that this is being lit at all. And you can kind of see this demonstrated if I turn off the line art. Even with cleanup, this one has a vague form that's not super easy to understand, whereas this one is a lot more clean and kind of feels like there's actually a box there. And again, this one just isn't convincingly being lit by anything. It's just in a room, and the room isn't the right color for this to make sense, so why would it look like this? If the room was black, maybe it would make more sense. But again, we're painting with a light, not with shadow. I'm not going to enjoy editing this. I messed up like so many times. I hope this was an explanation that made sense and covered all my bases clearly and concisely. My goal is to try to be concise with this series and yet explain things in ways that are simple and easy for people to understand with only a very broad understanding of physics. I don't want to go too in-depth into the math and science of it because I feel like it's not really necessary to be a good artist, but it's also important for me to talk about it because if you don't understand it, you aren't really going to understand how light works, and that's going to hold you back. Anyways, tune in for part 3 of the series, the actually interesting part.